Hello Internet! This is the first video of 2022 and I think it should be some provocative video. So let's have a look at 357 years of physics versus 2 years of large language models. I guess you are familiar with large language models. If not, have a look at the latest publication by MIT Technology Review. MIT was the year of monster AI models. My goodness, the monsters are coming. And as Will Douglas Heaven writes in December 21, 2021 in MIT Tech Rev, GPT-3 kicked off a new trend in artificial intelligence for bigger and bigger models. And I would like to give you one quote by a pair of Microsoft researchers. Hey, and if it's Microsoft, you know, this is first-notch research. We continue to see hyperscaling of AI models leading to better performance with seemingly no end in sight. And if you want to have a look at the Megatron Turing NLG 530B model, I have my own video on this. But if you think about a simple question, and a simple question is asked in this video by the YouTube channel Veritasium, where this presenter has here a giant circuit, a light bulb, a switch and 2 wires. And he asks a simple question. Hey, after closing the switch, how long does it take for the light bulb to light up? So, LLM, what is the answer? Now, the presenter makes this easy because he gives us an answer and he asks you, is it true or false? Could you ask an LLM, is it true or false? No, of course not. Because an LLM has no idea about the meaning of words, about reality, that words describe reality and whatsoever how language is constructed is within its realm. But what the words mean and what a physical system is, an LLM is absolutely no way able, even if it downloads the subtitles of the YouTube video and collects all the 15 minutes, the sentences in those 15 minutes, performs NLP, performs some transformer, retrains an LLM with this particular subset, have an optimal weight distribution. There's no way an LLM, any artificial intelligence, would be able to come up with an answer. And I will show you why. Because it is damn difficult, even now, for humans to come up with an answer. And I know you're not going to believe me. Hey, I switch on a circuit. When will the light bulb light up? But this is something that we as humans still struggle to understand. So 99% of YouTube viewers, I think, will come up with a wrong answer. I will show you this. 3 possible solutions. There was a frenzy on the internet and people were doing videos trying to justify their answer. But this is not the point, because this is about how we cope with problems. If we have a question, how do we try to solve it? Imagine you just have YouTube videos. Which of the dozens of YouTube videos that came out is going to be presented to you by YouTube's AI? I have here 3 cherry-picked videos I think are really, really special. On the left side, you see the video channel from Electroboom. I highly recommend this video. It is gorgeous. Have a look at this video where he tries to give his explanation, which is great. On the right-hand side is exactly the opposite. There is a guy who says, okay, I bought 1 kilometer of copper wire and I settled out to make this experiment, to lay 1 kilometer of copper wires in the field, do the experiment, measure the result, and be able to answer the question. And the video in the middle, of course, is a beautiful video I will come up with in a minute. But what I want to show you is, it is so difficult, even for us human, to come up with an answer to a question if it concerns the real world. And why is it? Because the system has parameters. And we have a lot of system parameters. And what is even more interesting, we have a lot of boundary conditions describing the physical system. But you know what? We do not describe the physical system with human language. We describe it in a different notation. We use mathematics. And so for you to have a first check if an answer given to a specific problem might be true. I present here some ideas. At first, the dimensionality of the answer. If I ask you a question, how many seconds will it take you to come here to me? And you will tell me 5 liters. I can guess that your answer is wrong because I ask you for a time period and you come back with a different dimension in your answer. So checking the dimensionality, meter over second square or whatever. First check, always do dimensionality check. Second, the geometric configuration in our example here, where you have these circuits laid out for a long distance, the geometric configuration in an electromagnetic field is of importance. It's highly important if you have some parallel transmission line, if you have a geometric like a circle, if there's some intra-twisted, whatever. So geometric configuration of the lines is of importance for the physical answer. The next one is the equilibrium of the system. Remember, when you start your car on a cold winter day, you have this and then your engine starts up. If the car is running for 10-15 minutes, the engine is warm, you have a beautiful of your engine, no problem at all, but it's a completely different state of the system that you are comparing with. And there are minimum 129 different effects. Yes, of course, this is just a number guessed. But let's say about the current. If you have AC or DC alternative current or not is important to understand the electromagnetic field around the transmission wires. It is so many other effects, the dimensionality of the wires itself, the skin effect on the wires, if you have some shielding, some multiple shieldings, some interference from some other electromagnetic fields. My goodness, even some cosmic rays event, if you have a solar storm, can have effect on the answer given if you're doing the experiment and you're looking for an answer. So what we learn out of this, describing a physical system, we can do it in 2 ways. Like the one with a human language, like presented in the YouTube video, he said, listen, I have here a giant circuit. I have a light bulb, I have a switch, I have 2 wires. What will happen? What? Now we know that there are so many parameters of the system is missing. The length, the resistance, the impedance, whatsoever, whatever parameter we have about this. What does it mean if the light bulb lights up? 5% of luminosity, 15% of luminosity, how many photons should be emitted from the light bulb that we can say, hey, it starts to switch on, how many nanoseconds after, what effect will happen, what is our time scale that we say, okay, now we noticed an event. There are so many parameters of the system, remember, 129. So a human language is never able to describe the system with the degree of detail that we need to find really an answer that we can make an experiment and validate the result. So what we do? We have 357 years of mathematics and physics, for God's sake. I mean, mathematics we have for more than 2,000 years. And if you count the Babylonian, when they watched out for their stars and their whatever, astronomy, we have close to 4,000 years. Physics and mathematics in different state. So this is amazing what we have. So why not use this powerful system that we have? So easily done. And you might ask, why 357 years? Well, you know, March 6, 1665, there was the first scientific journal in English published. And it is still the oldest to be continuously published. So I've chosen this date because we have some written down scientific publication where somebody discovered something and published it for other to examine, to have a critical examination, to do the experiment, to come back, to adjust the theory, to go back, do a better experiment, and so on. And we have done this at least for 357 years, if not 4,000 years, Babylonian, and so on. So let's use the power, this powerful tool, and not just guess around. And you know, the human language, the set of words that you choose, They are so sensitive. Is it an ordered set? What about the semantic complexity of the presenter? My goodness, human language can be so difficult to analyze. So let's look at physical mathematical system description. And of course, as I told you, doing an experiment is beautiful because then you know exactly about the temperature of your transmission line, about the diameter of your transmission line, about the isolation, about the length, about the humidity, about the temperature of the earth, about whatever you can measure if you have some shielding effects coming in from the outside. You can measure the accuracy of your hardware equipment, how fast it will produce if it's in the nanosecond or microsecond array. There are so many data. With an experiment, you can have so many characteristics of the system. This is amazing. You go back to theory, you check, you adapt to theory, you make a better experiment. This is powerful. And you end up with, like what we have seen here in EEV blog, recommend this video, have a look at this video, where you have the experiment like presented in the first video that we said that it's asks a question, how long does it take? And he is able to transform this problem into a lower dimensional complexity space. He is able to transform it in a space, in a topological space, where we can use our knowledge about electromagnetic waves. Where we have solved our Maxwell equations, we have come up with an engineering part with the different elements for electromagnetic. We can combine it, we can define a model that absolutely mimics the original proposed physical system, and we can play around with the model. He can have a software package, he can input the different values, and then he will come up with a solution. And you know what? If you have this model of a transmission line, the lumped element model that he's applying here, I guess he's an electromagnetic engineer. He comes up with a solution, and he shows you that up to a nanosecond, he can, or the system, what we developed over the last hundreds of years for electromagnetic currents, we find a solution. We can have down to nanoseconds time scale, find the correct solution. And this is nothing special. This is done in your university courses when you learn about Maxwell equations and so on. So you have to be able to deduct it, reduce the complexity, find a space where you can present your problem with simple elements that you know of, that we know the exact physical rules of, and you can then say, okay, the experiment will be given A, B, C, condition is this and this and this. The result will be in the time frame of 1 to 10 nanoseconds and whatever. This will be the result, and we have the perfect theory. And it is so easy. He calculated and he showed what the experiment will be. And the interesting part, of course, is, and this happens to me working in quantum field theory, he refers back to Feynman lectures. And I know it is funny, but you know, even I find myself checking out my old notebooks, or of course it's also on the internet, of Feynman lectures, and the clarity Feynman was able to present a topic and to describe a solution in such beautiful terms, easy to understand. Whenever I struggle, Feynman lectures are one of my go-to solution. And of course, there is also, especially for this particular problem that we encountered in our first video, there is given the pointing vector, and he points out, yeah, even Feynman found the solution in his lectures. And well, the pointing vector goes, of course, from the field inside the cable here, given this particular configuration of the system, and not as presented in the original video by Veritasium, that the pointing vector goes outside. This is a wrong presentation, but whatever. This is not about theoretical physics. But this is a very nice, so you find a solution on the internet, but you have to have a background knowledge. You apply yourself if you judge, hey, this is a great video, the way he presents it, the argumentation, the verification by an experiment, the theoretical explanation, the complexity, the reproducibility of all of this, that you say, hey, I go with this video gives me the definite answer, and it shows me the problem with the original video by Veritasium. But it's not about if somebody was wrong or right. This is about how we find solution given a set of YouTube videos. You have to know so much behind the scene, you know. You have such a knowledge graph in your brain about everything about theoretical physics. And even then you have to go and check Feynman's lecture to come up with a solution. I think it's gorgeous. But you know something else. And this is here, and this is a link to MIT Achievements of 2021. There is, and this is today, December 22, 2021. I found this today in my mail inbox, MIT News. And the top research stars for the Massachusetts Institute of Technology was, in 2021, 10 technology breakthroughs. And one topic was data visualization. And they showed in a study, and here you have the study reference, that the data visualization is not objective. It is not absolute. Of course not. It is in fact an incredible social and political endeavor. And we have to be attentive to how people interpret them outside of the scientific community. Of course, this is one of the challenges. If you do not have a system theory, if you do not have an exactly defined state of the system with all boundary conditions and initial conditions, whatever you as a human might and can interpret, you might and will interpret into the system if it is physically true or not. And just to show you that people who are developing those large language models, and I have here the publication from the Conference on Neural Informatics Processing System 2020, Vancouver, Canada. And here you have language models of few-shot learners. And there is a beautiful preprint of this, or the publication already, I guess, where they tell you that those LLMs, they have biases. And the biases presented in the training data, and remember, this might be, I don't know, all the sentences of all the people in Facebook, may lead models to generate stereotyped or prejudiced content. I mean, of course, if you have a training sentence from somebody on Facebook who might seem to be a little bit strange in his opinion, you have this sentence. And for an LLM, all sentences are equal. There's nothing better or worse. Sentences are equal. And if you have, I don't know, 1 trillion sentences or 10 trillion sentences from all people on Facebook, you can imagine what content is it trained on. And they go on, this is concerning since model bias could harm people. They could harm people in the relevant groups in different ways by entrenching existing stereotypes and producing demeaning portrayals. So you have to be careful because the system itself is one part, but the training data, if you load all of Facebook as the best sentences of our mankind, my goodness, I mean, you know the saying, garbage in, garbage out, no? I mean, what do you expect that a model suddenly becomes intelligent if you give it the content of Facebook to learn on? So this shows you that even those who develop the LLM are very aware of the problems that there are, and they are working hard to filter out some of the very polarized statement. Let's formulate it in this way. But this is a monumental task, and we are just 2 years into LLM, and I hope that it might give you an indication. We're just starting with LLMs, and given in 5 or 10 years, LLMs will get better. But LLMs need also a system where they understand somehow the relations in the world. They have to understand what a word means. And the human language, it develops with time, you know, it changes. And the way how you can express something is almost unlimited. and how you want to train this if you even have 100 trillion sentences. To understand what this sentence really mean for a specific person, in a specific group, in a specific circumstance, on a specific date, on a specific continent, within a specific community, looking at a specific event. Pure LLM, because this is really a monumental task that's in front of us. So now we come to almost the last one. Even clearest graphical visualization can be interpreted by human beings through a variety of belief systems. I always shake my head when I see the same political event in the United States of America presented by a news outlet in a version A, and then I switch to a different news corporation and they present the same event, but they interpret the event completely different. And I mean really completely different. It is amazing. So yes, there are a variety of system beliefs by news agency, by individual group of individuals, but single individuals, whatever, I have my belief systems. I don't think I'm always aware of my belief system. So it is so crucial to apply those apparatus that we developed in the last 357 years. And this is physics and mathematics. And this is why we invented physics and mathematics, to have an absolute precise description of the real world, that we have a systematic model of the real world where we can make prediction what's going to happen. This gives us an understanding and insight into reality. And I guess with data science and with LLM models and with artificial intelligence and deep learning and machine learning, you can see in the scientific literature that a lot of the physical and mathematical insights that we developed in the last 357, at least the last 357 years, those scientists applied also in data science. And this is the reason why I think in the next 5 to 10 years, we will have some significant breakthroughs also in artificial intelligence with large language models. Thank you, and I see you in the next video.